Bienvenidos, Ushamadid, and welcome Anne Arundel Community College learners from CTS-130, Section 402 for the Spring 2021 semester. This is the Cisco Networking Academy Introduction to Networks course, or ITNv7. In this tutorial, we're going to be taking a deep dive look at Packet Tracer Activity 2.9.1, where we're going to be configuring basic switch and in-device configuration settings. Now, this is going to mirror, in some senses, or in some respects, the activities that we've done leading up to this activity. In other words, Packet Tracer 2.5.5, as well as Packet Tracer 2.7.6. However, here you can see that we're being given less information with which to make our configuration decisions. So let's dive into the activity. You can see that we have our addressing table up here on the top right-hand side, and we're going to need this definitely. And our objectives, what are we trying to do? We're going to configure some host names and IPs. We're going to save some configuration information. We're going to use iOS commands, and then we're going to verify our configuration. So let's configure the devices to fulfill the requirements below. Now remember, requirements can sometimes be a little dirty, right? A little unclear. And so we need to make sure that we're paying close attention to what they're asking for here and execute on these commands. So it says, use a console connection to access each switch. Well, how do we do that? So up until this point in the course, we haven't had an activity that talked about using a console connection, or that actually used a console connection. And so to do that, we would click on the lightning bolt down here. Now remember, in most cases, the console port is located on the rear of the switching device. On some switches and some models, you'll find it as a USB-C port on the front, and maybe you'll find it on the front and on the back. But the little blue cable right here, that is my console cable. So it's an RS-232. You'll hear it referred to as a rollover cable sometimes. You'll also hear it referred to as that Cisco blue cable. And we'll connect it into the console port. But it is just an RJ45 cable that connects in, looks just like, similar to an Ethernet cable. And there is our console connection. And so let's add a console connection up here from user 1 PC into ASW1. And so these console cables are going to give us access to the console port where we can configure the device. Now you might be asking yourself, how would this be different compared to telnetting or SSHing to the switch device? Well, when we're on the console port, we're going to see all of the messages when a switch is booting, so that maybe we need to troubleshoot something that requires the switch to be rebooted. We could see all of those messages at boot time. When you're telnetted or SSH'd into a switch, those are things that when the switch is rebooting, you're not going to be able to see. And if you think about it, it makes sense. Remember, when we telnet or SSH in, we're using those virtual terminal lines, those VTY lines, and we have a connection over the network to the switch. But if the switch is rebooting and all of the ports on the front of the switch are not up and they're, in other words, down, being rebooted as part of the switch reboot, we will lose that connectivity. All right, so let's name our switches. So let's first pull up the config, and what happens? Configuration is locked. And so this is typically where learners run into their first hurdle, is they go ahead and connect the console cable, but then just figure, I'll click on the switch and do the configuration there, it'll be quicker. And while that might be true, this activity has locked us out of clicking on the switches. So we're going to actually have to pull up our PCs and give ourselves a little room with which to work, and we'll come to the desktop. Well, how do we take advantage of that console cable connection? Don't click on the command prompt, right? Because that's not where you would want to go. And this is the number one place where learners will go and then not be able to figure out why they don't see the switch command line interface. You want to come to the terminal, right? And you can see we have some settings here to communicate with the switch device. And these are typically the default settings on all Cisco devices over a console cable through the console port. So we'll go ahead and click OK. And now you can see that we are on the CLI for switch ASW-1. So let's go ahead and we'll go from user exec into privilege exec with the enable command. We'll go into global config with the configure terminal command, and then we'll add our host name. So the host name for this switch is going to be ASW-1. And again, it's probably going to be case sensitive in terms of you earning points. So highly recommended that you follow the case sensitivity. Now, we want to make sure that if we have any typos, that those don't get interpreted as host names, which then the switch tries to resolve with DNS. So we're going to say no IP domain lookup. Again, not getting any points for that, certainly not required, but it's going to make this a lot easier for us to work with. All right, well, let's go ahead and pull up the user 2 PC, and we'll do these commands one right after the other. So we'll come to the desktop, we go to the terminal, and we simply click OK. And here we are. So we go from user exec to privilege exec with the enable command, and then into global config with configure terminal, and we add our host name in, ASW-2. Now I'm going to say no IP domain lookup to make sure that we don't have any waiting around if we have a typo of any kind. And now it says use the, and that is a bizarre password for all lines. Now, by all lines, what do we think it means? Let's say do show run. Let's hit enter, and we'll go to the very bottom. So you can see we have the console line, and then we also have the VTY lines. And so my interpretation of what they're asking for there is both on the console line as well as the 16 VTY lines. We're going to use that as the simple password with which to get logged in. So let's go ahead and say linecon 0 and then password little x, capital A, little w, 6K. And let's hope we don't end up typing this a lot. All right. Now, again, don't forget, we need to say login, right? We need to say login. Excuse me. All right. So how can we go into the VTY lines? Don't make the mistake of trying to go into each VTY line one at a time and then try to run those commands. You can give a range of VTY lines. So line VTY 0 to 15. And now any commands I enter will apply this configuration to all 16 virtual terminal lines. So we'll set the password to XAW6K. And as you can see, we already have the login command there. So let's say do show run. Let's come down to the bottom and let's see what we've got. So the console line looks good. The VTY lines look good. And you can see that that line VTY 0 to 15 saved us quite a bit of time by applying the configuration changes to all 16 VTY lines at the same time. So let's come back over to PC 1 or user 1 and let's do the same thing. So linecon 0, we're going to say not login. We're going to say password. I want to do password first. Password XAW6K, and then we would say login. We'll say line VTY 0 to 15, and then we'll add the password in here, little x, lowercase x, A, capital A, W, lowercase w, 6, lowercase k. All right, so we've got that taken care of. So let's say do show run and confirm our configuration settings here. Now, one of the things we might want to do is go to linecon 0 and also add in logging synchronous. Again, this is going to help us when and if we see log messages coming to the console screen that might interfere with commands that we're trying to run. And so we're going to want to do that on both switch ASW1 and switch ASW2. So we would say logging synchronous. So let's come back over here to ASW1. And now the next thing we're going to do is use this random string here as our secret password. And so again, remember, we're not talking about saying enable password, right? Remember, we'll have two choices. It's going to be password and secret. If they're both configured, whatever's configured as the secret password overrides sort of the vanilla password that we would create. That would be a type 7 password with the password option. But we're smarter than that, and we want to make sure we use enable secret and then 6, capital E, capital B, capital U, lowercase p. And now we've set the password. So let's come over here to user 2 and we'll do the same thing. We'll exit back up to global config and we'll simply say the enable password, which is going to be a secret, will be 6, capital E, capital B, capital U, lowercase p. Now, it says encrypt all clear text passwords, because again, if I say do show run, and we take a look at this, you can see that all of our passwords right now are clear text. They're not ciphertext, they're clear text. So how do we do that? We say, it's not enable, we're going to say service password encryption. So now when I say do show run, we'll notice that the clear text passwords are now in a ciphertext. However, remember, these are type 7 passwords, and these can be cracked by simply copying the password and going out to any number of websites that are available. I don't think we have one up here, but let's just go ahead and say crack type 7 Cisco password. We'll come here, and again, to show you how quickly this can be done and ruin your day, there it is. Now, remember, you might be asking, okay, well, we've got these simple passwords set, and we're using type 7 passwords in order to obfuscate with the ciphertext here. However, if it's so easy to crack these, why does Cisco use type 7 passwords? Why are they even available? Well, remember, Cisco is very clear about the type 7 password and its application on their hardware devices. And it has to do with shoulder surfers, because something like this, XAW6K, might be a little easier to remember if someone's looking over your shoulder or walking by your desk than that random string right there. And that's really the purpose of the simple passwords on the console line and the VTY lines. Now, as you progress through the CCNA curriculum, we'll talk about what's referred to as AAA, authentication, authorization, and accounting, and you'll learn that there are better ways in order to achieve security with passwords. However, this is going to work just fine for us, not only in this activity, but in this first of the 3 Cisco CCNA courses. So we've encrypted all plain text passwords on ALSW02. Let's do the same thing over here with service password encryption. And now that's been taken care of. So it says configure an appropriate message of the day banner, right? Well, all of the keywords for the command are in there, banner MOTD, and we're just going to say authorized use only. Log off now. All right, so that's going to be our message of the day. We'll do the same thing over here on user 2. So banner MOTD, and in between double quotes, we're simply going to say authorize use only, log off now. And so now we have our MOTD that a user will see when they go to connect to the device, and so that they know that if they're not authorized, they should be logging off. We're going to configure addressing for all devices according to the addressing table. So now we're coming back to these switch virtual interfaces. Now, in the previous activity, 2.7.6, they were referred to as switch management interfaces, which you can use. However, SVI, V as in Victor for virtual, the SVI is the most commonly used acronym to describe what it is we're doing here. We're creating a virtual layer 3 interface that is created and runs in the software, the iOS software on the device, that allows us to connect to the device via an IP address. Compare that to using the console cable like we are here. In order to use this console cable from the PC, we would need to be pretty close to the switching device. However, if the device has a switch virtual interface, an SVI, configured with an IP address, then we can either Telnet or SSH to the device in order to administer it. So let's take care of switch 1 first. And remember, this is different from creating VLANs. This is creating a switch virtual interface. And so we're going to say interface VLAN 1. Now, once we're in here, we're going to put our IP address on here of 10.10.10.100, and that'll be followed by our subnet mask in dotted decimal notation. And for right now, remember that 255.255.255.0 in dotted decimal notation is referred to in CIDR notation, CIDR, as a /24, because each of the first 3 octets, which individually consist of 8 bytes, add up to 24. So 24 of these bits are being used to describe the network. And so our network would be 10.10.10.0. The broadcast address would be 10.10.10.255. And so then from .1 to .254, we have a usable range of IP addresses. And here we're using .100, meaning we can't use that again, at least in this VLAN, which is VLAN 1. Remember, VLAN 1 is the default VLAN for Cisco switching devices, and all ports are by default in VLAN 1. If I said, do show VLAN brief, you will see that all the ports are listed as being in VLAN 1, the default VLAN. All right, so we've configured the IP address. Now, remember, in the other activity, if I say do show IP interface brief and pipe that to include only VLAN, you can see that we see our switch virtual interface, we see the IPv4 layer 3 address, but then we see it is administratively down. So how do we resolve that? Well, we don't simply say up, we say no shutdown, because shutdown will administratively shut the port down, whereas no shutdown will administratively bring the port, in this case a virtual port, virtual interface, bring it up for us. So now if I was to rerun my do show IP interface brief and pipe that to include VLAN, and again, we're looking for any line on which a capital V is followed by a lowercase l, a lowercase a, and a lowercase n. Refer to, you'll hear me say, a string. We're looking for that string of characters, but it is case sensitive. In fact, if I was to come back and say VLAN with a lowercase v, look what happens. We don't get anything. So it has to be exact. It has to match case-wise, right? And so we have our match right there. Now our interface is up. So we've taken care of the first switch. Let's take care of our second switch. So interface VLAN 1, IP address 10.10.10.150. It's a /24 with a dotted decimal subnet mask of 255.255.255.0, and we want to bring this interface up. So do show IP interface brief, pipe it to include VLAN. Now, how else could I see that? I could say do show run, and we can go all the way down here to the bottom and then have to scroll back up and get to where we need to be to see, okay, there it is. Okay, things look good. Or you could simply say do show IP interface brief. and then scroll all the way to the bottom to see that it's up, up. And again, we get a whole bunch of other output here that we're not really interested in. So remember, that include is kind of saying, give me only lines that have that exact string somewhere on the line. It doesn't have to have the 1. In fact, I could pull it back to just VL. That's enough to make it unique, but yet still match in some way that line that says VLAN 1 with the IP and gives us the additional information. All right, so we've got our switch virtual interfaces configured. Now, it says it wants us to configure the, what am I trying to say? The PCs. So let's close our terminal line down. We'll come to the IP configuration, and let's put in the IP address for user 2, which is 10.10.10.5. Now, remember the comment I mentioned earlier in the, or I should say in the previous video about what you're about to see here. You're going to hit the tab key, and it's auto-magically going to drop in that dotted decimal subnet mask value of 255.0.0.0. Now, it auto-magically does that, but it puts the value based on the classful boundary of what this address would be. And a 10 dot address would be a class A. So it puts it in as a /8, 255.0.0.0. Well, we know that we are subnetting this to a 24. So the first 24 bits are going to reflect network bits. And that's why we have to change that to the 255.255.255.0. So now let's go over to user 1 and let's make the same change. We'll close the terminal down for now. We'll bring up the IP configuration for 1, and that's going to be 10.10.10.4. And again, watch out for this because that would be incorrect because we're using a /24, and you got points for that setting right there, by the way. So if the subnet mask gets left off, you're going to find that you're going to be missing some points. All right, so we've configured the IP addresses according to the addressing table. Let's save our configurations. Well, to do that, let's pull the terminal back up here. And you can see we pick up right where we left off because we don't have any kind of a timeout message set on the console line. So let's go ahead and say end. And that takes us to privilege exec mode here. Remember, if I say disable, where is that going to take me? Is it going to log me off? Does it put me in global config? Or does it put me back in user exec mode, where I would have to enter the enable password that we've configured? And so let's make sure this is working. 6EBUP. And it does. So let's save our config. Again, I could say copy running config, and the running config is running in random access memory, in volatile random access memory. So the startup config, which is an NVRAM, gets pulled into memory when the switch is booted. And that is the running config. But we want to save a copy of that to the startup config. That way, if the switch is powered off, if it gets reloaded, the startup config, again, that is what is copied into volatile memory, and that is the configuration the switch uses when it boots up. Very, very important to save a copy of your configuration, your running config, to the startup config. And you can see we were thrown a few points for that as well. Now, there's no saving we need to do technically on the PCs. Again, if you were on a Windows 10 PC, I'm sure it would have, click OK to save the settings and things like that. These PCs in Packet Tracer aren't going to have that. So the configuration that we've entered, once we enter it, unless we change it on the PCs, that's going to be the configuration. So now let's come over to user 2. Let's jump back onto the terminal window here, and there's different software that you can use in order to connect via the console port. They call it terminal here, but there's many different programs. One of them is PuTTY, P-U-T-T-Y, and PuTTY is a free terminal emulator. Another one is Secure CRT. Secure CRT is sort of the Ferrari, if you will, of terminal emulators, and it is expensive. I think it's about $100 to purchase a license for it. But PuTTY works great as well. Here, we're just using this program they call, it's called Terminal, right? And so you could also use and I'm drawing a blank right now on Windows. It has that, not dialer. I want to say dialer. I can't think of it because I don't use it. Maybe it'll come to me, but there's another program already on Windows that you can use as a terminal emulator, but not one that I would recommend. Okay, so let's go ahead and type N to get the privilege exec, and the alternative way to save our configuration is to say write memory. Let's see if we get any points for that. And it gave us the points. Again, copy, running config, startup config, know what this is, know how to run the command, know what it's doing, but also know that you can shorten it by just saying write me or wme, right? As in write memory. All right, so that has put us at 100%, but let's drive on here. There's more to talk about. So save our configurations, verify connectivity between all devices. And so we can do that from PC2. And let me go ahead and close this window down, and let's pull up the command prompt. And so it's here that I'm going to say ping 10.10.10.4. Now, remember, everybody's in VLAN 1. This connection between these switches is not a trunk link. It is an access port. And I'm going to show you that here in just a second because we're going to build on this conversation, gearing up for creating multiple VLANs, and then how do we allow multiple VLANs to run between switches to be passed over that single link there. So I can ping PC user 01, and now let's ping 10.10.10.100. Can I get the switched virtual interface on the ASW1 switch? And I can. And remember, that request timeout is an ARP packet, most likely, because we're trying to get that layer 2 information. And what about the switch to which I am directly connected? And that's ASW2. Can I ping ASW2? And now I have all the information I need. If I type ARP-A, I have all of the other IP addresses, but more importantly, I have the relationship between the layer 3 IP address, the network layer, and the layer 2, the data link layer, MAC address. So I know which layer 2 address, which MAC address corresponds to the layer 3 IP address, because that is how layer 2 switches are forwarding your traffic. They're doing it using the MAC address. It's not until that frame gets to the destination that the layer 2 header is stripped off, and then the PC looks and says, yeah, I see that that's my MAC address, so I'm going to strip the layer 2 header off. It's meant for me, but now I need to peek in at the layer 3 and see what's the source address and what's the destination address. And those are fields, those are immutable fields, meaning they don't change unless we're doing NAT. Those fields won't change on you. Source and destination. Again, network address translation is a topic for a later course, but in our scenario here, the source and destination IP addresses in the IPv4 header, meaning if I'm pinging from PC or user 2 to user 1, the source would be 10.10.10.5 for user 2, who's initiating the ping, and the destination is 10.10.10.4, user 1. But when that traffic is traveling from user 2 up to user 1, these switches don't care about the IP address. These are layer 2 switches. Even though we've configured a switch virtual interface that does not turn these switches into routers. Routers are very concerned with IP addresses, but layer 2 switches are all about layer 2 addressing. And remember, another fact is that on each of these switches, we have a MAC address table. So here is the layer 3 information for user 1, but here is the layer 2 information. 85 Charlie Delta is what the last 4 hexadecimal characters are in this 48-bit MAC address. So when user 2 tries to send traffic, that traffic is going to go to the switch. And now I want to get back on the switch here because we want to look at that MAC address table again. So show MAC address table. Well, how would I get to 85 Charlie Delta, right? And I'm just referring to the last 4 hexadecimal characters in the MAC address here. And so this is how ASW2, this switch, learned about this MAC address, and it knows that to get there, it sends traffic out fast Ethernet 02, which is this port right here. And then that traffic would be sent over here to ASW1. And let's look at ASW1, and let's see where it is going to send traffic that it receives with 85 Charlie Delta in the MAC address, in the layer 2 frame, the physical address. And it knows it sends it out fast Ethernet 02. So how could we confirm, again, in a lab environment, that fast Ethernet 02 actually connects to user 1? Well, there's a couple of things we could do. What we know how to do right now at this point in the course is I can go into interface fast Ethernet, 02, and I could shut that port down. And that right there conclusively shows you, yes, fast Ethernet 02 is the port on ASW1 that the user 1 PC is connected to. So we'll say no shut to bring it back up. And that orange dot that you're looking at, that is the waiting dot. And what are we waiting for? We're waiting for spanning tree, a topic that we'll cover a little later on. But we're going to be here for, well, I should say, we're not going to sit here and wait. I'm going to talk about other things, but it's going to be about 30 to 45 seconds before we see that orange dot turn into a green upright triangle. So what do we want to talk about next? Well, we want to talk about this link between these two switches. And I said that it's an access port because all we're doing here is extending the broadcast domain. And remember, think of a broadcast domain as a VLAN, as a subnet. These are synonymous terms. So a subnet is a VLAN, is a broadcast domain. And we're all in the same VLAN, VLAN 1. We haven't changed any VLAN configuration on either switch. And so how can I see what the mode of that port is? So if I was to say, do show MAC address table, and actually let's get out of interface config mode there, and let's get all the way out to privilege exec. So you can see that the only thing I know about right now in the MAC address table is the connection over here to ASW2, out fast Ethernet 01, because we already know this is fast Ethernet 02 on the switch side. And so you can see that I am connected to the other switch on fast Ethernet 01. So what if I was to say show switch port, or show interface, sorry about that, show interface or interfaces switch port, and now I can actually match on certain criteria, or, and it doesn't like that, so it's going to force me to do that. So we're going to have to show everything about that port. But again, here you can see show interfaces switch port. In other words, you're saying show me about how this port is configured. And it would show all ports on the switch, but luckily we're interested in the very first one, so we don't have to figure out where we're at. And you can see right here is the operational mode of the switch. It is a static access, meaning that it is not a trunk port. So it's an access port, and what VLAN is it in? It is in the default VLAN, VLAN 1. So all we're really doing is daisy chaining these two switches together, using all of the default settings for the most part, and specifically with the VLANs, and then we just plug in two PCs, and everything will work, right? Everything is going to work, and we'll have reachability and connectivity. All right, whoops, there's our password cracker. All right, so that is going to do it for Packet Tracer Activity 2.9.1, where we took a look at basic switch and in-device configuration, and we're walking ourselves up to the point where we no longer will need to open a terminal window to manage the switch via a console cable, but rather we're going to be able to Telnet or SSH to the switch. In fact, if I was to step back to the activity, close that out, pull the command prompt up, what might happen if I say Telnet to the 10.10.10.100? Well, you can see we get prompted for the password. What was the password for all the lines? It was XAW6K. And look at that. I'm able to Telnet to the switch. And I'm able to do that because of that layer 3 switched virtual interface, the SVI we created for VLAN 1 on each of the switches. In fact, I can ping the other switch. I can also Telnet to XAW6K and administer that switch as well. So pretty cool. All right. Well, again, that's going to wrap up this packet tracer activity. Thank you for watching. Hopefully this has clarified a number of the concepts that you've been reading about and learning about in the course. And if you have any questions, please ask. If not, thank you for watching, and I hope to see you in the next video.